In this video, we're going to go over all these different kinds of data visualizations. We're going to put the emphasis on Seaborn. There are ways to produce similar graphics using the plot method or matplotlib, but Seaborn has a couple advantages. First, the figures in Seaborn tend to look better by default. There's less we have to do to make it look really professional. And also, the syntax for Seaborn tends to be very straightforward and easy to use. So we're going to go over scatter plots, line plots, distribution plots, and heat maps in this video. Okay, a scatter plot looks like this. So I'm taking the first 200 rows of my ANES data. So 200 people. For all 200 people, they've given the two candidates in the 2020 presidential election a rating from 0 to 100 that represents how much each of these 200 people likes Biden and Trump. So we take the two ratings and then we can use those as X and Y coordinates and plot the points. So this is the simplest scatter plot we can make with Seaborn. We use the SNS scatterplot function. We define X, we define Y, we define the data. Here we go. Now there are a number of things we can do to improve this plot. First, we can use the fig size and the labels and title, and that makes it look a bit more professional. We could also use color coding. So we could add hue equal party ID, leave the rest of the code the same, and it does two things. One, it generates a color coding for the Republicans in red, the Independents in green, the Democrats in blue, and it gives us a legend for that. So that's all we have to do to get this kind of color coding. We could also use shapes. So here we're going to denote the men with dots and the women with X's. All we have to do is use style. Instead of hue, we would say style and then set it equal to the feature that we want represented with this particular aesthetic. Now, I don't recommend using this unless we also use color. Because the X's and the dots are so small, it's hard for people to tell the difference between these two things in general and to get a sense of the story we're trying to tell. But we could do both. So in this case, I'm saying both hue and style are set to party ID. And now, instead of just colors, we're using colors and shapes to represent the three parties. We could set color to be one thing and style, the dot style, to represent a different feature. And this is a way to input, to represent even more data in one figure. So here we have colors for party and then shapes for sex, and there's a lot of information here. It's definitely too much. This is a confusing figure, so this is not something I would recommend. I think that if you're going to use this, it's better to use both hue and style for the same feature, because that's going to increase the contrast, help people to see the difference between groups in your data. Now, I want to talk about the parameter alpha. Alpha controls the transparency in the graph. Now, transparency might seem like a very funny thing to be messing around with. So I'm going to show you what we use transparency for. This is a scatter plot with absolutely no transparency. And this is all of the data, so there's a lot more here. Transparency shows us clusters in the data. When alpha is equal to 1, then I've got a perfectly solid point. When alpha is equal to 0, I have a perfectly transparent point. Anything in between is a degree of transparency. So 0.1 is going to make each point mostly transparent. When I make the points partially transparent, areas in the graph with more data become darker. So if I want to see where are the most common areas in this overall scatter plot, I use alpha equal 0.1, and it shows me. So I've got a big cluster up here. These are people who rated Donald Trump very, very high and Joe Biden very, very low. As we saw before, these are also mostly Republicans. It makes sense. I also have a cluster down here. These are people who rate Trump very low. Now, what's interesting is among these people who rate Trump very low, there's quite a lot of disagreement about how they like Biden. All that they agree upon at this point is that they don't like Donald Trump. I think that makes sense given what we know about this election. We also have a very small cluster of people who said 50-50. So people who I think generally have no real opinion between these two candidates. So that's what transparency can do for us. Now, there are a few other aesthetics that we can look at. We can play with size, and we can set the range of sizes from 40 to 360 in terms of radii. I think that's millimeters, something like that, by age. So the smaller size circles, and I also set hue to be age. Smaller size circles and lighter colors are younger people. Bigger circles, darker colors are older people. This graph is mostly just to show that we can play with size as well, but I don't think it's an especially interesting or understandable graph. Okay, another really cool thing that we can do with scatterplots is we can include a line of best fit. So to include this best fit line, I would change the function from SNS scatterplot to SNS regplot. By default, it's going to draw a straight line, and that straight line is derived from a simple linear regression model in which the y-axis is the y variable and the x-axis is the x variable. It includes an intercept and a slope. And so this line right here can be interpreted as the more somebody likes Joe Biden on average, the less they like Donald Trump, which makes perfect sense. The shaded region around the line is the 95% confidence interval of the predicted mean given a value of x. So if I want to predict the expected value of the Trump thermometer, the average value of the Trump thermometer, for somebody who rates Biden at 60, I start at 60, I go up to the line, and then I go over and I see it's about 30, maybe a little less than 30, like 28 for the Trump thermometer if somebody's rating Biden as 60. The shaded area means that the 95% confidence interval on the mean ranges from about 25 to 32, like that. Now that is the confidence interval for the mean, not for the prediction itself. As we can see, most of the people around this line rate Trump a lot lower than that prediction. Right? It's just saying that if we had more and more and more points, the average of those is predicted to be here. Now that still might be wrong because this figure shows a straight line, and so there are ways to get something other than a straight line, which I'll show you in just a second. So here's one way. If I write order equal 2, then instead of a straight line, it's going to draw a quadratic curve, a parabola. And so that bends the curve a little bit, not too much, but it bends it a little bit. And so it brings the prediction down a little bit, closer to 20. And then the other way to do this is with something called LOS. LOS stands for locally estimated, oh shoot, why did I put myself on the spot? Oh yeah, locally weighted scatterplot smoothing. That's what it means. Now, the way LOS works, essentially we're only looking at a local area of points, and then we're going to take the mean of the x-coordinates and the mean of the y-coordinates, and we're going to plot that in a rolling window all the way down the graph. And that allows a LOS curve to bend non-parametrically in exactly the way the data moves. So just wanted to show you that if you wanted a non-linear fit, you could write LOS equal true. Now we can also put scatter plots into a matrix. And so we haven't talked about this yet, But this is an extremely useful function from Seaborn. It's called facet grid. This allows us to put different figures side by side by side. Now, to use facet grid, the first argument is the data that we're going to be plotting from. So that's the ANES data frame. Then we can specify row and column features. In this case, I only want party ID to be represented in different columns. Now, I could say that there's another feature represented in the rows, and there are examples of that in the notebook that I encourage you to look at. Height controls the height of each of these individual plots, and aspect is the ratio between the height and width. Okay, so first I set up the facet grid. That sets up the grid into which I'm going to put individual plots. I set that equal to a variable g. Then I can write g.map. That's going to tell me what I'd like to put inside each grid. So inside each cell in the grid, I'm going to put a scatterplot, SNS scatterplot. I'm going to tell it the x and y variables and then additional parameters such as alpha equal 0.1 and that the points should be black. That gives me 3 different figures, one for Democrats, one for Republicans, and one for independents. Okay? And so we can see where the Democrats cluster, where the Republicans cluster, where the independents cluster. A couple other things. If I write g.setTitles column name just like this, then it replaces the default labeling of the graphs with the name of the category of party ID. So Democrat, Republican, Independent. Okay? And then I can set the axis labels. So I can write that the x-axis is the Joe Biden thermometer rating, the y is the Donald Trump thermometer rating. And then these two set an overall title for the graph. Subplots adjust is what I need to do to make sure that this title here does not overlap with Democrat, Republican, and Independent. And then here's where I can type the overall title and the font size. So that's a way to get a grid. Okay. Now very quickly, let's go through some of the other graphs that we can create. Let's start with line plots. So to create a line plot in Seaborn, I just write line plot. I can define the x-axis and y-axis variables. So in this case, I've got by age of voter, the average Biden thermometer, right? Now, this is a little bit misleading, the way we talked about in the first video, because the y-axis does not represent the full range of the thermometer rating. So I could change that. It really ought to go from 0 to 100 if I'm trying to be accurate. So to change that, I can add PLT-YLIM 0, 100, and then it's the same data, now starting at 0, going to 100. Okay, so it just shows that there's not a whole lot of variance by age in terms of the average rating of Biden. Now, if I want to put multiple candidates on the same graph, I have to create a data frame that looks like this, where I have different candidates and the thermometer ratings. This is in long format. The way I would create data in long format is to use the PD-melt function that we talked about in Module 9. I won't get into that here just for time, but just to show you, if I take only the rows for Trump and for Biden, and I plot those, and then I use hue candidate, then it gives me something that looks like this, where I've got from 0 to 100 by age of voter, the thermometer rating for Biden in blue and for Trump in orange. And so here it shows that for younger voters, Biden is preferred to Trump on average, and for older voters, Trump to Biden. Okay? I could put hue and style set equal to candidate, and then it changes it both color-coded and a dashed line for Trump. Okay, so the only thing that changes here is I've written hue and style for the same feature. And then I can put all 4 on there if I just don't use query to restrict what the data refers to, because I put 4 candidates into this ANES line data frame. Hue and candidate, and so I've got 4 different colors, 4 different line styles for the 4 candidates. Now this figure here can be very confusing because it's just too much going on. So I'm going to use facet grid again with candidate to represent the columns, but also with column wrap set equal to 2 to create a 2x2 grid of these 4 line plots. So here, facet grid, column by candidate, column wrap 2. That means show me 2 graphs and then go on to the next row. Okay? And it produces this figure: Biden, Trump, Barack Obama, Bernie Sanders. Okay, there are examples in the notebook of how to make distributions and how to make heat maps. Let me just very quickly go over those. To create a histogram, you would write SNS dist plot. A histogram is a figure that shows the overall distribution of a feature. So in this case, I've got the Joe Biden thermometer ratings, and it's showing me that there are a lot of people who rated him 0, not that many who rated him 100, and a lot of people who rated him somewhere in between. Now, an important distinction with histograms is how many bins to use. So I can create more bins to show more specifically what's happening at different parts of the distribution. But if I use too many bins, it starts to break down and I don't see much of a picture at all. So here's an example of using too few bins right here. I've set bins equal to 3, and this doesn't really show what's happening with Biden. This is too many bins, so bins is 300, and it breaks down. It doesn't show me at all. But if I use something like in the middle, like 50, it would show me a bit better. Okay, this is an example of facet grid by candidate with column wrap 2, and it's showing me the histogram side by side for all 4 candidates with different colors. Okay, now I will let you look at the code for the following graphs. For the rest of this, I'm just going to show you the picture just to give you a sense of what is possible with Seaborn. A density graph looks like this. It is built on top of a histogram, and it uses the heights of the bars, and it draws a continuous curve on top of them. We can use the SNS KD plot to put a shaded region, and it's very useful to plot overlaid shaded regions. So I can do this for Biden and Trump. Okay, you could see KD plot, and you can look at the code yourself. But this overlay density plot shows me that there are more people who rated Trump very low than Biden, but there are more people who rated Trump very high than Biden as well. Trump occupies the extremes more. Biden has more people who rate him in the middle. So anyway, that's a density plot, and that's what these sorts of graphs are useful for. We also have violin plots. A violin plot is like a density plot, but it is symmetric. So it draws the same shape above and below. And then in the middle, it shows us a thin black line representing the min and the max at the edges, and then a thick black line that ranges from the 25th to the 75th quartile, so the interquartile range, and then a dot to represent the median. Now we can put different violin plots next to each other with this violin plot, okay, by candidate. And so here we see the Trump, Biden, Obama, and Sanders violin plots all next to each other. So you can see for Trump, more people around 0, more people around 100. though more people at 0 than at 100. You can compare that directly to Biden right next to it. Also Obama and Sanders. Okay? Now the last thing I'd like to talk about in this video is a heat map. So a heat map is used to plot a matrix of continuous values. So for example, I'm pulling out a correlation matrix for all the feeling thermometers, starting with the one for Trump, extending through the one for the NRA. And I have this correlation matrix here. If I pass that correlation matrix to the SNS heat map function, then it gives me a visualization of that matrix, right? Where the rows and columns refer to each of these feeling thermometers, and the values are color-coded based on how high or low the correlation is. There's always going to be a color scale next to the heat map, ranging from very dark colors to very light colors. We can change that scale, and there are examples of that, but this is a way to wrap our head around a whole lot of data contained in a continuous matrix like a correlation matrix.